Yeah. Okay, let us, I think, first settle what we may do this week for our lab class. But let me tell you first what plan to do in the whole lab course. The short demo on spectrum analyzer, and then uh, there is a tool. Cambrium Networks is something who provides some tools for free. One of them is a simulator for LOS link. Okay, their simulators are pretty good, although they are free. We have to resort to something that are free. Okay, uh, okay, and they also have a tool to simulate Wi-Fi network, the wireless environment for Wi-Fi. So on 2 separate days, we will do experiments with these two tools. And then there is a simulator for uh, radio environment. I mean, it is popularly used for non-LOS environment, although it can also simulate LOS links. It's called NYU Sim. Okay. The key feature of this simulator is that it can support up to 150 gigahertz. The high frequency ranges were not in use in the past. You know that the satellite links, or I mean this kind of long distance LOS links were only supporting some high frequencies, but those are also mostly tens of gigahertz. Okay, 20, 30, 40 gigahertz. Above that, frequencies have recently, there are, of course, research work, but for commercial purposes, there are almost no uses for frequencies even higher than that. But nowadays, you know, especially 5G is introducing frequencies, is introducing the use of very high frequencies, up to 100 gigahertz. But there will be more, I mean, there will be in future the use of even higher frequencies. Okay. And there is some considerations for frequencies up to 150 gigahertz. So this simulator, I mean, it is based on some good research. So its outcome is reliable. Uh, it can support up to 150 gigahertz. So we'll do experiment with that too. And finally, we will do an experiment with a radio network planner for cellular network, a radio network planning tool, RNP tool for cellular network is ATOL. So this is what we planned so far for our whole lab course. So with that in mind, I think we don't have any rush. We have enough time. And for this week, I was just thinking that some students may feel lethargic because in the beginning of this we had Eid, and so maybe we start our lab classes from next week. That's just a thought, but what do you think?
জি স্যার নেক্সট উইকই ভালো
Okay. Okay. So then you have to set up the LOS link tool. Okay, it's called Link Planner from Cambium Networks. I'll share a link today. Please download that and install, and then you have to create an account for yourself. You will need to send a request to the authority of Cambium Networks. In a day or two, they will respond with some token, which you need to activate all the features of your tool. Okay, so please make yourself ready with the tool before we do our experiment in the next week. Okay, Wednesday and the next week. Meanwhile, if you have any difficulties, please let me know. I mean, to use the tool, please let me know. I mean, you don't have to use it, but just get ready with the tool. Okay, let's begin our actual discussion. Last time we were actually just, I'll just touch upon a couple of things that we were living with. First, the Shannon capacity. Okay, I have already shared the link. And, I mean, this page I shared in the Google Drive. I mean, we showed that it's a relationship between digital data rate and the frequency range, actual frequency range in hertz in the spectrum. And we know that that depends on SNR and how you implement the technology. I mean, this is the maximum theoretical data rate, but how close you can get to depends on your technological strength. So your practical data will be smaller than C. So this relationship, but I mean, this relationship is impractical, but this one is practical, where you can relate. You can use some proportional relationship. Okay, at least to relate W or S by N with your practical data rate. Okay, now you know. I mean, there is a how this as you change your SNR. Okay, I mean, there is a logarithm term which you need to use to find out how it will affect your data rate. Okay, the other thing that we were discussing in our last class was like uh, the selection of, sorry, the use of higher frequencies uh, these days. I mean, with time, now we use high frequencies. Now, one last slide, I think we did not discuss last time. Let's see if we use satellite communication. Okay, it uses typically FTD. So the downlink uses one frequency range, and the uplink uses a separate frequency range. Okay, so is the case for usual cellular networks. Now, my question is, which one do you prefer between the? I mean, you'll have two separate frequency chunks, one for the use of downlink, the other for the use of uplink. Okay, so my question is, which one do you think will be more suitable for using the downlink for satellite communication or for cellular communication? But let me clarify what I mean by downlink and uplink. See, there is data transfer from satellite to the Earth station, and also data transfer from your Earth station to satellite. Okay, so when it is from satellite to Earth station, it is the downlink data transfer, and when from Earth to satellite is uplink. Okay, so now in the case of cellular communication, what do you think? Which one will be downlink? Your base station and your mobile phone.
The receiving side would be downlink, sir.
Well, both sides receive, don't they?
The mobile phone.
Yeah, the mobile phone. When the mobile phone receives and the base station transmits, is called downlink. And when your mobile is transmitting, but you know, in this case, sometimes it may happen that I mean, you are in a high-rise building and on an upper floor, and the actual base station is at a level lower than your position, but it is still downlink. Okay, which is not the case for satellite. Anyway, now the question is, for satellite communication, you have two separate chunks of frequencies, and of course one will be higher than the other. Now, say if I mark them as higher frequency part and lower frequency part. For example, maybe uh, say 12.2 to 12.4 gigahertz, and 12 point and say 14.2 and 14.4 gigahertz. Okay, so two separate, for example, two separate chunks. So 12 is the lower side. So now tell me which one between downlink and uplink will be more suitable for the downlink, for the lower part frequency chunk.
We prefer the downlink to be stronger, so we'll choose the lower part for downlink probably.
Okay, so you want to make sure that you can hear well. Okay, so from the earth station you are hearing, so you want to make sure that you can hear well. So the lower frequency chunk you choose for, because we discussed the lower frequency better, so you choose it for your downlink, right? Right, Minhas? Minhas, do you hear me?
Yes, sir.
Yes, okay.
Yes, sir.
But how, don't you think that the satellite also needs to hear you well? If the satellite doesn't hear you well, who will suffer? Is it you, or the satellite is not a human being, but will that suffer, or ultimately it's you who is gonna suffer? If the satellite doesn't hear you well, if the satellite,
Ultimately, it's me, sir.
yeah, ultimately it's you. For example, if we talk about the broadcast, say the TV broadcast satellite. So in that case, the TV stations are transmitting. So if the satellite does not hear this information properly from the TV broadcast stations, what will it send it to you? What will it send to you? It doesn't have the correct information. It has some erroneous information. So it will send you the, so you receive properly the erroneous information, right? Ultimately, it's you who is gonna suffer. So now what do you suggest? Or anybody else?
Sir, both are important, but in practical cases, for example, say we are browsing internet. Actually, we send the data we send to the server is very low compared to the data we receive. Like we receive big contents most of the time. So the downlink is a bit of more importance, I
No,
think.
both sides are equally important. Both sides are equally important. If you say you inquire something, okay, and so if it is incorrectly received at the other end, that will, the other end also will also respond in a wrong way, which you don't want. Both sides are
Yes, sir.
equally important. Okay. And it may be another, say you may be talking with someone else, okay, with your friend. So how will you feel that you can hear him well, but he doesn't? So it don't make sense. You don't know what to say, right? If you don't hear him well, you don't know what to say.
Yes, sir.
Okay, so okay. Anyone else? Anybody else? Okay. Now let me answer. In fact, when the purpose is different. Minha's answer was correct. Is the downlink, which is used for the lower frequency part, but the reason is different. Well, between when you send your signal, the other side has to receive. Uh, Give me a second. I need to turn the fans off. Okay. You need to use enough power for your transmission so that the received power is enough. Okay. Now, how much power? But there will be some path loss on the way. You transmit with some power, but the signal will lose some power on the way. Now we know that if we have lower frequencies, then the path loss or the power it loses on the way will be lower. So if that is lower, I need to use less power for transmission. Now let's check which side is more power conservative, which side has more difficulties to spend power. Between satellite and earth station, which side is more power conservative, which side has more difficulties, or there is more power scarcity, okay, or more difficulties to supply power?
Satellites.
The satellite.
Because that depends on solar power, okay, merely solar power. But at the earth station, you're connected to the bulk power generation. So if the downlink, when the satellite transmits, okay, and it consumes its power for transmission, if you favor the satellite, okay, if you allow him to use a lower frequency range, okay, it will consume less power. It will consume less battery. The battery life will also be longer, and your total energy requirement, design, okay, the design will also be less expensive. Okay. Now, answer me the same for cellular communication. Again, it's the downlink, right? Guys,
Sir, could you kindly repeat the question?
which side should use? Cellular communication, mobile communication typically also uses FDD, a lower frequency part and a high frequency part.
Yes.
I also have uplink and downlink here. Please suggest me which side between uplink and downlink should use the lower frequency part.
I think the cell phone.
Yes.
Yeah. So in terms of uplink and downlink, answer me in terms of
So the uplink.
uplink, right?
Yes.
Now it is the uplink.
Uplink. Yes.
Yeah. So that uses the lower frequency part. Okay. So your battery life, you need to recharge less frequently. Okay.
Sir, I have a question.
Yeah.
So is the uplink and downlink like receiver dependent? Sir, for the satellite is if it's receiving data, so it's downlink for the satellite, right? Or so is it like for a fixed?
No, it's fixed.
Okay.
Okay. For satellite communication, when you say downlink, it always means that the satellite is transmitting and earth station is receiving.
Okay.
Okay. So is the case for cellular communication. So that is what we had on this last slide. Okay. Now we will begin our actual lecture for today. We'll talk about the radio wave or electromagnetic wave. But we will have a very simple discussion, okay, to let you feel comfortable. Okay. The key purpose is to have to remove any discomfort. Okay. A lot of people are not comfortable with electromagnetic wave because electromagnetic, I mean, these things we don't see. Okay. And secondly, wave is also something that many people are not comfortable with. Okay. You know what? Many people are afraid of electrical engineering because, I mean, in the case of mechanical engineering, people can see the stuff that is rotating or moving. Okay, so what they work with, civil engineers or mechanical engineers, so they work with something which are visible, but the electricity we cannot see, the current. Okay, we cannot see. So some people are scared and they don't choose electrical engineering. But the current people, most people, I think, visualize. Okay, although they don't see the current flow, they visualize. Okay, most people uh, visualize like some ball shapes, electrons are moving. Okay, most of you also do like that, although it's not like that, you know. But most people visualize current this way, right? However, even the electrical engineering students, okay, who are not afraid of this thing, that they take it, but some of them are still afraid of electromagnetics. Okay, I mean uh, the part of electrical engineering which deals with the fields, electric and magnetic fields, because these fields even people don't visualize. Okay, so electrical engineers may be visualizing current, okay, and they're okay, they accept working with that, but some of them are scared about this electromagnetics because they cannot even visualize. Do you visualize fields? You don't, do you? Okay.
Sir, like, not, we can't do it exactly how it is, but
No, I don't mean to say you whether you can do it or, I mean,
Yes, sir.
people don't do it. Okay.
no, we don't do it. Yes, sir.
Yeah, you cannot even visualize current properly.
No, exactly.
But
sir. Now we
people,
can't.
most people visualize, at least I
Yes.
do. Okay. Now,
Yes, sir, with the arrow, sir. Yes.
yeah, I mean, it's okay. Anyway, so the purpose here is to make you feel so people are not comfortable, okay, with the electromagnetic stuff. So the purpose here is to let you feel comfortable. Now, I'll start with a question. Please tell me, what do you understand by reactive power? For the real power, I mean, it's a first year question. The real power, all of you understand clearly that the energy is converted into some other form. So per second, this amount of joule energy is converting. So you have some, there's the, I mean, watt, okay, for your real power consumption. But if you have, say, 5 watt, you can explain 5 joules are converting every second. But if there is 4 var of reactive power, so what is happening there?
Energy is stored in terms of magnetic field in inductors and electric fields in capacitors that we cannot use.
Okay. Then why cannot you? Why can you not use this thing? I mean, if the power is stored, then how? I mean, does it keep storing? Does it keep building up the storage?
No, sir, it oscillates, sir. stores and then when the energy leaves, then it stores again.
Right. You're absolutely right. And I'm happy that you have answered it correctly. Uh, the energy oscillates between the load and the source. And 5 var means 5 joules of energy is flowing back and forth between the load and the, so the load is storing, the load is building up energy when, I mean, in one cycle. In the other cycle, it is giving it back to the source. Okay. So from the source end, there is really no power loss of power. Okay, it's getting the whole power back. Okay, but you also must understand that there will be some losses on the way because the line is not practically lossless. So as the reactive power goes back and forth, okay, the line will incur some losses. Okay, so high reactive power is not good because it increases the line loss. Also, the line capacity needs to be higher. Okay, so that's why power factor correction is necessary. Anyway, so now we understand that as you already suggested that the power is stored. Okay, so the power is stored in the fields. So it's very good that you understand that the fields can store energy. Okay. So both electric and magnetic fields can store energy. If that is the case, so capacitor stores energy in electric field, inductor stores energy in magnetic field. If that is the case, if you, I mean, when you have the fields in the air, they should also be able to store energy in the air, or they can contain energy in the air. And if this field propagates, then they can carry energy for you. Okay, so that is how you can actually transfer energy. So the electric and magnetic fields can be used to transfer energy from one point to another. And then the energy transfer will be wireless. Okay, you don't need any conductor for the power transfer. So this is the key concept. Okay, and however, normally you don't use this power transfer for real to fulfill the requirement of power at some other end. Okay, we'll discuss why. I mean, because of actually large path loss on the way. That's the reason. So most of the power you lose. But for information transfer, okay, the energy you get at the other end can be used to retrieve some information. Okay, and very low power is sufficient for this purpose. Okay, so that's the basic thing. So do you see the electromagnetic wave slide, the first slide?
Yes.
Okay.
Yes, sir.
Okay, so this thing. Now these fields, electric and magnetic fields, they keep on varying. And these variations follow a wave function. We'll shortly show you a typical form of wave function or basic form of wave function. And these fields, since they can store energy, but I mean, the stable circuit, as we discussed, store energy in one cycle and release it in the other cycle. Okay. Now, well, if you have a circuit with one inductor and one capacitor, okay, and nothing else, you connect it to a source. So we are just considering a simple series circuit with inductor and capacitor connected to, okay, connecting in series and then you connect them to a source. Okay, so current was flowing. Suddenly, you short circuit the source. So in the circuit, then you have only inductor and capacitor. But current was flowing. So we know that the current will not die out instantly. Okay. And if it is really lossless, then okay, let's consider the circuit completely lossless. Okay. Purely you have inductor and capacitor. Can you tell me what will happen? What will happen to the current that was flowing?
It will oscillate back and forth forever.
Yeah, it will keep oscillating back and forth, and that will continue forever. So in that case, what will happen to the energy storage? How the energy storage will continue? Okay, how will any? Sorry, I got disconnected. Do you hear me now?
Yes.
Okay.
Yes, sir.
Okay. Now, tell me what will happen. I mean, we are considering a circuit, okay, where there, I mean, we have shorted, and we have now only inductor and capacitor. So current is flowing back and forth. Now, can you explain it in terms of energy storage in the circuit? Okay, what is happening to the energy?
The inductor and the energy will be oscillating between inductor and capacitor.
Right. So energy will keep building up in one cycle in the, say, inductor, and in that cycle, capacitor will be releasing its energy.
Yes.
In the next cycle, capacitor will be building up, and the inductor will be releasing. In other words, the electric and magnetic fields exchange their energy, right?
Yes.
Because we have electric field in the capacitor and magnetic field in the inductor. The same occurs in the case of electromagnetic wave. You have electric magnetic fields in the wave which can store energy, and they keep on exchange of their energies. Okay. And as they do that, the composition moves on. Okay. So it's like, I mean, you have, I mean, so as they do that, they have the energy either